Hello, everyone. This webinar was due to start at 4 p.m. We do have a few more people trickling in, so we will get started within the next minute or so. The Customer Service Manager at CPM Rosscamp Champion, and I wanted to go over some housekeeping tips for the webinar. First off, welcome and thank you for joining the webinar. During this, everybody will be on mute, so if you do have any questions, feel free to use the chat function located in the upper right part of your screen. The questions will only be seen by the presenter and not by the participants. We will monitor these during the webinar, and we will stop to answer all of the questions at the end of the webinar. I may also be typing some answers back to you directly. This webinar is being recorded, and you will receive a follow-up email with a link to the download of the video after the recording. Be sure to monitor your junk mail to filter through this email. And without further delay, Doug Kitch.
Hello, good afternoon, everyone, or good evening, and I believe for a few of you, good morning. Today, we'd like to talk a little bit about the different variables that come into play when you're trying to attain a different grind profiles out of your hammer mill. As most of you are all aware, screen size is a very important one, but I want to go over a few of the other things we can look at if you need to adjust your grind a little bit. So the items we're going to go through today, I'm sorry, I guess let's start here. First things first, as always, please make sure you are always properly locking out and tagging out your equipment before you're opening it up or performing any maintenance or service on the machine. We never want to hear or see anyone getting hurt, so please always make sure you are safely shutting down that equipment and locking it out before you service it. So we'll go over a few points of terminology that we may be going through throughout this presentation. So real quickly, a couple of the main components. At the top of, I guess first, this is our grinding chamber. As you can see here, we have our rotor, our hammers. This rotor is spinning in a counterclockwise direction. Up here at the top, we can see our flow director or diverter, however you would like to call it. This is the down side of our hammer mill. The hammers are swinging down at this point, and this is our upside. We may reference this regrind chamber down here at the bottom as well. And some of the things I'll go talk about at a few points throughout this webinar is this primary destruction zone. This is where a vast majority of the grind is actually happening in your hammer mill. So this is, you want to think this is where the biggest impact is with the material and the hammers. We'll circle back here a couple points. So I just want to make sure that that is noted. But now, the different variables I plan to talk about today are shown right here. This list will pop up a few times, so none of you have to feverishly write them down as fast as possible. So first thing right here, tip speed, we're going to start with. So what is tip speed? What does tip speed mean? What it is how fast the hammers are spinning inside your hammer mill. Now, the example I'll use to try to describe a little bit and why it's important are, let's say you are driving a car down the road and you get in a car wreck while you're going 30 miles per hour or 48 kilometers per hour. There's going to be a fair amount of damage to your car. There's going to be some broken pieces and whatnot. Now, if you're driving the exact same car down the exact same road and you get in the same wreck, but this time you're doing 70 miles per hour or 112 kilometers per hour, there's going to be a lot more damage to your vehicle. There's going to be a lot finer pieces, a lot more broken pieces. Well, the exact same principles apply when we're talking about hammers in a hammer mill. So you'll hear it a lot, and so when we talk about tip speed, we're just trying to make sure we're always comparing the same thing when you're talking hammer mills. So 3 of our common size hammer mills we have out there are, can everyone hear me? I'm getting some feedback that we're not okay. I see it says my audio is working. So we have our 38, our 44, and our 54-inch hammer mills. I'm just going to give you some baseline information with these at 1800 RPMs, which would be a 60 hertz. The tip speed of our 38-inch is moving up just under 18,000 feet per minute, or 91 meters per second, which equates to about 203 miles per hour. Our 44-inch at 1800 RPMs is just under 21,000 feet per minute, or 105 meters per second, which is about 235 miles per hour. And then our large 54-inch machine at 1800 RPM is over 25,000 feet per minute, 129 meters per second, or right at 289 miles per hour. Now, if you kind of go back to that example I just gave, you have some big in the speeds of those hammers. So as you can imagine, a hammer spinning at 289 miles per hour as compared to 203 miles per hour, there's going to be a big difference in how that material is ground. So that can make a big difference in your grind. And I do want to stop right here real quick and say a good majority of those of you who are attending are in the animal feed industry. So we're mostly in the grain grinding. So I apologize to everyone else that's grinding other various products. I tend to lean a little towards the grain grinding. I promise all of these principles do account and are adequate for the various products you're grinding. I'm just mostly going to talk about the grain. I will try to reference them as I can, but I apologize if I do lean a little towards the grain grinding side. So to show you an example of what the speed difference and what it can change in your grind, I guess real quick here, these do cover the other various sizes of hammer mills that we do offer. That example I showed you was an 1800 RPM motor in a 60 hertz environment. So depending on where you guys are at in the world, you may be 50 hertz, you may be 60 hertz. Depending on your diameter of your machine, you may have different size motor too. So this shows that tip speed. Everyone listening, you should be somewhere on this scale to see about where the tip speed of your machine is. I do note that these are all in feet per minute. I apologize for anyone looking for meters per second, but these are all in feet per minute. So what is tip speed and how does it affect your grind? Well, this example here, those are 3 different grind profiles from 3 different samples. Now, the only difference we made when grinding these is we changed the speed of the rotor. So we had the exact same quantity of hammers, we used the exact same size screens. The only thing we changed was the tip speed. And as you can see, we got 3 pretty different grinds. We had a very fast tip speed where we got 841 microns, which is shown in the gray line here. A moderate and medium tip speed is shown with the orange line at a little over 1100 microns. And then we had a slower rotor where we were about 1400 microns. So as you can see, you have a difference there of almost 600 microns just in mean particle diameter, and that was only from changing the speed of the hammers. So you'll hear that quite a bit when someone, if you're trying to compare someone's grind, you both might be grinding with the same size screen, but you might have vastly different sizes just depending on what some of those variables are. Some other data points. I got this from the University of Auburn. They ran some tests with the same setup where they were using a 7.9 millimeter screen, and then the variables you can see in their chart, they each had different tip speeds, and you can see that the different grind sizes they saw a difference of about 400 microns between the different speeds they chose. Now, with all that, and knowing that that's really important as to what kind of grind size you can get, you might ask, all right, well, how can I change it then if that's so important? And unfortunately, the answer for most of you is you cannot. That number is fixed. The size of the rotor is the size it is, and it's directly driven from the motor. You can't change that speed. Some of you might be fortunate enough to have a variable frequency drive or an inverter already hooked up to that motor, and you can use that to slow your rotor down. I know that it's pretty popular right now, especially in the animal feed industry, that we're looking to get a much coarser grind. And a really easy way to do that is by slowing down the rotor. That's a really simple way. You don't have to change any variables, any screens, hammers. We can simply slow down the rotor. So if you're already equipped with a VFD, variable frequency drive, it's a great way to change the grind without having to turn off the machine and change other settings. And I will note, anytime I talk about a variable frequency drive, I'm only going to reference slowing the rotor down. We don't want to see you speeding up that rotor faster than what that machine was designated to run. For most of you, that's either 50 or 60 hertz, depending on your environment. So we only want to use the VFD to slow the rotor down. Now, you guys might be thinking, well, I don't have a variable frequency drive, but can I put one on? I can't answer that for you. The machine can handle it, but you need to make sure that the motor you have is capable and compatible with a variable frequency drive. If it's not and you install it, you may lead to some premature motor failure, and then you're going to have more problems. Another thing you have to keep in mind, that bottom bullet point, is you don't want to spin the rotor too slow. Usually depending on the application, but I'll say this a lot, it depends, but 1,000 RPMs is kind of like the bottom where we want to see it. So you don't want to spin it too slow. You could have some other adverse effects there. Moving on to the next variable is the hammer pattern, or the quantity of hammers that are in your machine. How many of you right now, this will be a rhetorical question, but know how many hammers are in your hammer mill? Have you ever changed it? Has it always been the same? Those hammer patterns are adjustable. For each hammer mill, we have approximately 4 or 5 patterns already designed. And when we're sizing up a hammer mill before the sale, we'll go through and choose the quantity of hammers we want to have in the machine. So it's very possible that the hammers that you have in your machine now were the same ones that you've always been using, and there's a good chance that that may not be your best setup. We're always happy to review that with you to see if there's a different pattern that may better meet your needs. An easy way, like I just mentioned, if you're really trying to get a coarser grind, one of the first things we actually might look at doing is removing hammers. If we can have less hammers in there, there's less working surface area. It will help us get a coarser grind. On the opposite side, if you're looking to get a finer grind, and I have the ability to add hammers into that pattern, that's the easy thing to do. It's one-time thing. You change them, you're good until that pattern's done. With that, you have more working surface area in there, and you're going to get more fines will be created, which is going to help you get a finer grind. Now, one thing I will also mention is if you're adding more hammers to get that finer grind, there's a good chance that you will see a reduction in throughput through your hammer mill. For the most part, anything you do to get a finer grind will also come at the cost of a lower throughput. Now, we can also remove hammers, like I said, to get a coarser grind, but that also could have some adverse effects in the hammer hole and pin wear. If any of you are seeing any images or issues like this with your machine, there's a good chance we have an improper quantity of hammers in your machine. And an easier solution to this is to simply add hammers to that pattern, because we're spreading out the workload over different hammers, which will prevent the rocking that you're seeing on the pins, which is creating those grooves. So we do have to be careful in removing hammers to try to get a coarser grind, as there could be some premature wearing that we'll see. But one thing I will say in regards to the hammers and tip speed is the hammer quantity and speed of those hammers are two of the most important variables when it comes to determining what grind size you're going to get from your hammer mill. For the most part, those were selected by my team, the applications team at Roscamp Champion, before the machine was sold. But like I said, that could have been designed 10 years ago and may not be the best now. So if there are some of you out there running our large 54-inch hammer mills with a very heavy hammer pattern, you may notice you're trying to get a coarser grind and you can't. And a lot of that is just due to the speed of those hammers as well as the hammer pattern. So you could take the screens out and you could still not get as coarse of a grind as you're looking for. So these are two very important variables that we need to make sure we understand. But I also want you to know that we do have some options and we can look at them. Now this one is fairly common, is the hammer condition. You know, if you're having poor quality hammers in there and they're not in good shape, well, you could expect to not get a good product out of your hammer mill either. So I won't touch on this too much, but just making sure that you're not using those parts longer than you need to be. That's a whole nother webinar we can go through on operational costs. That the longer you keep those worn parts in there, the more money they actually cost you. For the most part, just real quickly on this slide, this is what a good worn hammer looks like. The hard facing on this side is gone. It's gone on this side. There's just a little bit of hard facing left on the middle of the hammer. We consider this hammer worn. It needs to be replaced. If any of you have ever pulled a hammer like this out of your hammer mill, you waited far too long to replace that hammer. As you could imagine, the amount of grinding that this hammer was doing was essentially none. So, you know, that will also affect the grind size that you're getting from your machine. So making sure you're being proactive with replacing wear parts is very important. Another quick diagram to show that the standard wear we like to see, the one on the left shows that little bit of hard facing left in the middle of the hammer, whereas the one on the right is what we consider to be excessive wear. Now, another issue that this could have is as you're losing wear or losing part of the hammer as it's wearing, you're also changing the tip clearance between the tip of the hammer and the inside of the screen, and you can see some plugging issues. I'll get there in a few slides, but I just want to bring that up, that see some adverse effects with running a worn hammer too long. So with this one picture, I just wanted to show real quick. If you look on the left side, you'll see the hammers are in very nice condition. There's still a good amount of hard facing left on them. You can see up here. But if you look way over here on the right, these hammers are severely worn. Outside of the obvious issues you can see here, one thing I want you to keep in mind is the material that's being ground right here with these hammers will look very different from the material that's being ground right here. So right there alone, just by having some bad hammers in there, you're making two different grinds in the same machine, not more than 12 inches, 1 foot apart from each other. So making sure you have good quality parts inside your machine is really important to getting a good end product. And then same with this next picture. If I can get the slide to change. There it went. The hammers that are shown here are in pretty rough shape. They've had some damage to them, and you could easily suspect that you're going to get quite a few different grinds from this machine just because of all the different length of hammers you're seeing there. So making sure you aren't running parts in there longer than they should be. If you've got some damage in there, you need to replace it right away. Now, I just referenced hammer position and hammer clearance in your hammer mill. So for most of you, you should have a rotor that has a fine position and a coarse position, and that the fine position has hammers closer to the outside of the rotor, and the coarse position has the hammers farther away from the outside. So if you look at this rotor shown on the left, let me get my laser pointer back. You'll see that this has 12 pinholes total. 6 of them are in the fine position and 6 are in the coarse. The one shown right here is the coarse position. As you can see where this pinhole is located, if you rotate it around, you will see that this one is farther to the outside, which would be the fine position, which will have your hammer closer to the inside of the screen, so there's not as much of a clearance. The difference in those positions I have listed right down here on the bottom. Now, for the most part, pretty much everyone there, every one of you was sent a rotor that had both a fine and a coarse position. However, there are probably a handful or a few of you that either went with an all fine or an all coarse rotor. So it is possible that not all of you have this option, but I just want to let you know for the vast majority, most of you do have this available. Now, you might be asking, what does that hammer clearance do and how can it affect my grind? Well, for the simple answer, like we just talked about, there's a difference in tip speed. By having those hammers a little farther out, you do see a difference in speed. It's minimal. It's only about 100 feet per minute or half a meter per second, but every little bit counts. I mean, that could be a difference of, again, sticking with the feed side, we could be looking at, 15 to 20 micron difference just because of that little bit of speed. But the biggest reason that they change is actually the exit angle of the material. So because those hammers are farther away from the screen, the material has a more optimal angle to get through the screen holes. The material does not see a perfect circle, but rather it sees an shortened elliptical opening. And if you really want to think of it this way, that little piece there can act as a backboard. So the material almost bounces through. So what you're seeing here with that optimal angle, you have all this material can easily get through the hole of the screen. Now, when you move those hammers farther towards the outside of the rotor and you decrease that clearance, that material no longer has as nice of an angle and it really has to make a sharp turn to get through those screens. And what's going to happen is some material won't make it through that hole. As you can see with this example, this material actually hit on the inside of the hole or before it even got to the hole and bounced back up into the grinding chamber. Now, when it bounces back into the grinding chamber, it's going to get hit by the hammers again. And when it gets hit by the hammer again, it's going to grind again. It's going to get finer, but it's also going to take more energy because it's getting ground again. So as I mentioned earlier, you'll get a little bit finer of a grind, but it's also going to cost you some throughput. And now as far as changing that, if you do have a rotor that has a fine and coarse position, you can simply move the hammers to one or the other. It's pretty simple to do that. And if you don't have one that way, we can always supply you with another one. I realize that's not the cheapest option, but it is possible to do. Now this one's very common. Hopefully all of you are familiar enough with the Hammermill to understand how the different sizes of screen holes can affect your grind. But a few things I do want to point out with them. Putting in a larger screen with larger hole diameters in there does not always mean you're going to get a coarser grind. Now, when we were talking about earlier, if you have a really heavy hammer pattern with a fast tip speed, at a certain point, you won't see that grind get any coarser. You could essentially take the screens out of the machine and you will still see the exact same grind. So that's why I always try to, before we move to getting larger screens to get a coarser grind, I'm actually going to look at some other variables first, because one of the other effects of going to a larger hole diameter will be a larger standard deviation. You will not have as homogeneous of a grind. You'll have a lot of fines, but you'll also have a lot of larger particles too. So your average size may stay the same, but you're going to see your standard deviation increase and really be non-optimal. And at a certain point too, if you get too large of screens, you may be seeing whole grain or whatever product you're grinding, much larger pieces than you want will start to pass through. Now, I did reference a minute ago running without screens. We really suggest you do not run without screens. I know it may not seem like a big deal, but actually what you'll see is if you don't run the screens, you'll start to wear not only your screen carriage, but the inside of the door on the Hammermill. And we'd rather you wear the screens and replace those than the doors. But just to kind of summarize this slide and screens in general, screens are certainly one of the easiest variables to change, but they may not be the best solution for you long term. We get it quite a bit. People want a different grind. They call in, just want to change screen size, and that's great for the short term, but I really suggest you reach out to our applications team and find out, is there a different variable we can look at? Just because, like I said, screens are quick and easy, but may not be the best solution. Moving on to screen area. So this one's, again, relatively self-explanatory, but it's the amount of screen you have inside that Hammermill. How much room is there for that material to get out? This one certainly is a fixed number. It was, again, sized by the applications team before the sale. So that's you can't change it. You can maybe decrease it a little bit with a couple techniques, but this is a constant that you cannot change. But just to keep it in mind, to make sure if you are comparing your grind to someone else's grind, um, it is a variable that comes into play. But typically for a coarser grind, we're going to have a higher amount of screen area in relation to the connected horsepower or kilowatts. Whereas for a finer grind, we like to have a lower screen area, so there's not as much area for that material to try to exit the grinding chamber. We want to try to keep it in that grinding chamber a little longer so it gets impacted by the hammer another time or two. So not only is there screen area, but there's open screen area, or the amount of holes on the screen, if you want to think of it that way. So I will ask another rhetorical question is, which hole diameter do you think is larger? The ones on the left or the ones on the right? I'll let you really inspect them here for a second, see what you think. And the answer is neither. Both of those holes have a 7mm opening, but they look different, right? Well, that's because the one on the right has a lot more holes than the one on the left. They're a lot closer together. So again, you're going to ask, well, what does this matter? What does this mean? Well, the one on the right has a lot more open area. This would have a higher throughput than the one on the left. If you want to think of it, if you have 2 buckets of water, you drill 10 holes in one bucket and 4 holes in the other, which one will empty first? The answer is the one with the more holes, because there's more opportunity for that material to escape. So the same as with your Hammermill screens. Now the downfall here is this has a lot of open area, but there's also not as much material in between those holes. So this screen is also going to be weaker because there's not as much material holding it together. So there's a big trade-off with screens. You can have a high amount of open area, which will give you a higher throughput. With a higher throughput, you're going to get a coarser grind because you can get that material out of the grinding chamber quicker. The downfall is your screens are going to be weaker and they won't last as long. Or you could have, like on the left side, a lower amount of open area. That's going to come with a lower throughput. You'll get a little bit finer grind because that material can't escape the grinding chamber as well. And then you'll also have stronger screens because there's a lot more material holding them together. So keeping that, another pitfall with some of these is if you're not getting OEM screens, you can't guarantee what those open areas are. Someone down the street may be able to sell you a screen much cheaper, but do they have the right amount of open area? Do they have too much? Do they have too little? Some way or another, I'm sure they've can try to cut a corner to make it a little cheaper for you. So just keeping some of these in mind when you're out there looking around. Similar to the hammer wear we talked about earlier, is screen wear is another important factor. We talked about that image on the bottom left. It should all look familiar to you. That material is going to try to bounce through the hole in the screen. It's got a nice sharp edge there on the inside, but as that wears, that's not going to be a sharp edge anymore, and it's going to start to round out. And what's going to happen when that rounds out is some of that material, instead of bouncing through the hole, it may bounce and stay in the grinding chamber. And like we talked about earlier, when it stays in the grinding chamber, it gets hit by the hammer again, you're going to get a finer grind, and then you're also going to reduce some capacity. So most of you hopefully kind of see that when you're monitoring your screen wear and your grind size, you notice they get finer for a little bit and you're also losing some capacity. So understanding that if you're getting a finer, coarser grind, they're going to change a little bit, but knowing what happens as those screens wear. Moving on to screen orientation. This one is often overlooked. I want to make sure you guys have the correct hole pattern on your screens. Now, if you look closely, the one on the left is different from the one on the right, and I'll show you why here. So again, if we look at the one on the left, this is the correct orientation. If your hammer travels moving top to bottom, no matter where some material comes, it will always see an opening of that hole. And that way it has an opportunity to leave the grinding chamber. Now, if you look at the one on the right, you could theoretically have a piece of material would go right down this spine right here and never see the opening of a hole. Now, what that's going to do is that's going to keep that product in the grinding chamber longer, so you will see a slightly finer grind, but that's also going to cost you some throughput because that material can't get out of the grinding chamber. And this might be, 4 or 5, up to 8% difference in capacity, but that's quite a bit. It does add up. It may seem small, but it will certainly add up on you. And the other problem you're going to have here is because you're having material slide up and down between these holes all the time, this part of the screen is going to wear very quickly. So you'll actually start to see those screens split open if you run them too long, in which case that's not the way you want to wear your screens. You're going to have to replace them sooner than you want. So making sure, again, if you're buying OEM screens, I can guarantee they're all going to look like this. But if you're looking elsewhere, there's a chance you may be getting these, and I want you to avoid that if possible. Now, aspiration. This one, everyone's got it. I guess not everyone, but most of you have aspiration on your Hammermill. But a lot of times we see it where not everyone knows exactly what it's doing. So we want to use aspiration on a Hammermill to not only help pull the product into the Hammermill, but help pull that ground product out of the Hammermill. It's helping us pull the material through the screens. And just to kind of keep it simple, a higher amount of aspiration is going to pull that material out of the grinding chamber quicker, which is going to result in a coarser grind because that material is not staying in the grinding chamber longer than necessary. If you have a lower volume of aspiration, that material won't be pulled out of the grinding chamber as fast, so it's going to stay in there longer. As the saying goes, it's going to get hit by a hammer again, and when it gets hit by a hammer again, that's my place here, sorry, getting button pushy. It gets hit by a hammer again, it's going to create a finer grind, you're going to lose some throughput. So aspiration is really key into how your Hammermill is operating. So maybe worth checking. How much aspiration do you have on that mill? Is it enough? Is it too little? Should we look at getting more? Kind of the rule of thumb has always been 1.25 times the screen area of your Hammermill is what we tend to look at. And then you can add or subtract depending on your application. So if we look here, oops, I gotta get my laser pointer back. You have aspiration coming in, and this is showing one of our pocket feeders. So with various feeders, there should be some sort of air inlet. But we want that air to come in with the product into your Hammermill, into your grinding chamber. It's gonna come with the product, and it's gonna pull, the air's gonna take the path of least resistance and try to get through those screens as quickly as it can, hopefully pulling a fair amount of material with it that's ground to spec. Sorry, go ahead. Mouse back. So next question is, what do you need to do to either increase or decrease the amount of air coming through your Hammermill? The first thing is, like it shows with the picture on the right, do you have a damper on your fan? Can you open or close that, depending what you need to do? We talked a little earlier about a variable frequency drive or an inverter on the motor. Does your fan have one of those? It could be another simple way to increase or decrease the amount of aspiration. Or even you could maybe look at some of the drive shifts on that fan to see if you can change this. Now, one thing I will say is air is not as simple as turning it up or slowing it down. You do need to check with the fan curve and potentially your supplier to make sure that you can gain more aspiration. See where you are on that fan curve to see if it's possible to increase the airflow through that machine. But a couple of the other things we can check are any air inlet locations in your system, whether it's different places where seals could be worn, even some worn holes in your ducting, potentially some bleed-in lines. Check those to see, are you pulling air from places you don't want to go? Like I mentioned a few slides ago, air will take the path of least resistance. So while you may seem simple enough that it's going through your Hammermill, there's a good chance you could be bypassing your Hammermill. So using air locks where necessary as well. I know it's very common to see a discharge screw that you're using the material to create a plug, and those work fairly well, but an airlock would always be better. So checking your system to see if there are ways that air could be bypassing your Hammermill, because like we said, you want that air to come in with the product and help pull it out of the grinding chamber. Now, we talked earlier to make sure that any changes you make could have some other effects downstream. So before you guys all hop off your computer and run out and try to increase your airflow through your Hammermill, do make sure that not only that your fan can handle it, but also that your plenum and your filter can handle it. When you increase the aspiration volume, you will increase the velocity of air in your plenum, which is going to pull more fines to your filter, which could plug it. So before you run out and make a lot of these changes, do check to make sure that your downstream components can handle it as well. Now, all of you should have air inlets that look like either the ones on the left or the one on the right. The one on the left shows our Champion series where the vents are up here towards the top of the door. And on our HM series, it's this right here on the right. Now, the aspiration that will enter into these ports is already on the outside of the screens. So it won't actually help you with pulling product out of your grinding chamber. So any air that comes in here is actually designed to kind of be clean air to help sweep off the outside of the screens or the inside of the doors. Typically, if you're getting some wet material in or you're seeing some buildup in the inside of the doors is where you'll use these vents. So I just want you to understand that the air you pull in through here is not actually going through the grinding chamber. Now, I don't actually list this on my list of variables, but just talk about how important preventative maintenance is. Because if your engine's not running at all, you definitely will not be getting the grind you want. Just picked a couple pretty extreme cases of some failures we've seen out there, which obviously neither of these hammer mills were running at this point, so they were not getting the grind you want. So make sure you guys are being proactive and not reactive with your preventative maintenance. Now, switching gears a little bit, moving away from the physical characteristics of the hammer mill and moving a little to your incoming product. Again, I apologize, this is going to focus more on the grain and feed side, but it's applicable across all material. Not all material is the same. We just talked about how corn is not always corn. There's dent corn, sweet corn, popcorn, but even beyond that, not all dent corn is the same either. On the feed side, I can see the difference in how material grinds if it's in Ohio as compared to Western Nebraska or different climate differences. So, you guys might see it when you switch to a different bin that you're grinding from, or if some of you are grinding wood here, depending on the age of the trees you're grinding. So we see a big difference in this, what we would quote unquote call the same material. So understanding there's going to be some variances in what you see from the grind, just depending on what material you're grinding. If you want to think of it this way, if you change the incoming material, expect the outgoing material to also change. This next bullet point is very important, especially for the grain grinders on here. Mixing moistures does not average out. If you mix 14% corn with 18% corn, or any material, I should say, it does not equal 16% moisture. It doesn't work that way. Don't let your buyers convince you otherwise. But one thing to keep in mind is usually for about every 1% increase we see in moisture, you could expect a 10 to 15% loss in efficiency or throughput is what you see. So knowing what that moisture does, but a big one here is the temperature. And again, this one's often overlooked, is when that material is colder or down around 0 degrees Fahrenheit as compared to 80 degrees Fahrenheit, we ran a test on corn and we saw about a 20% difference in energy efficiency when grinding those products. The difference is that the material, sorry there, I lost my laser. Hot and wet material does not grind as easy as cold and dry material. So keeping that in mind, even looking at some of your climate locations where you guys are at, you'll see a big difference. If it's for those of you kind of in a very hot and humid climate, you may see different grinds you get with the same material as someone who's in a very cold and dry climate. So again, a lot of this is if you're trying to compare to someone else's grind, just knowing that that hot, wet material is more difficult to grind. So when it's more difficult to grind, you're not going to see as many fines. It's not shattering. You're almost tearing the product a little. But when it's cold and dry, that material is a lot easier to grind and typically will shatter better, which is going to result in more fines produced. So even the quality of the product you're grinding, like I just said. So and a lot of this is just understanding when you change the incoming product, expect the outgoing product to change as well. Now this last one I'll go through doesn't actually change your grind, but how you perceive how your grind is changing. Where are you pulling your sample from? Are you pulling it from the same location, the same way? If you have a couple different people at your facility pulling samples from different areas, well, you could expect to see that grind size change, so to speak. Whether you're pulling it before the filter or after the filter, or after the product has been allowed to segregate. So just making sure you're staying consistent, and then making sure you're even sieving the same way. And this is really important when you're trying to compare your grind to someone else's grind at a different facility. Julie Calavoto at Kansas State University did a some phenomenal research a few years ago on the effects of sieving and the different ways you can perform that sieve test. It's a really nice paper, and it really goes through just really saying that you need to make sure if you're comparing your grind to someone else's that you are measuring it the same way. What was the biggest point I could tell you to take away from it is making sure if you're comparing to someone else's that you are talking apples to apples. Now, real quick in summary, before we move on to some questions, I've seen a few pile up here already, is make sure you're always properly locking out and taking out the equipment. The screen size, while a very easy variable to change, may not be your best one going forward. There's a lot more to determining a grind size than simple screen size, so making sure we understand that. Anything you do to create a finer grind will typically result in a loss of capacity, so there's always a trade-off there. And again, that the way your machine was set up when you originally purchased it, or what you needed for a grind 10 years ago or 10 weeks ago or 10 days ago may not be what you need now, which also means the way your hammer mill is set up may not be ideal as well. So please always feel free to reach out to our applications team and customer service team. I know a lot of you, it's real quick and easy to just order a different size screen, but a lot of times let's take a look and see how we can set up that machine to make sure you're running as efficiently as possible. So, and finally, like I said, be proactive, not reactive. So for now, let's take a look at some questions. If any of you do drop off, that's fine. You all will receive a copy or an email here in the near future, next couple hours. Do check your junk mail, but it will have a link that does allow you to download the recording from this, so you can view it again if you want. Otherwise, let's take a look at some of the questions.
Okay, Doug. So I'm going to read some of these questions, and if you can provide your answer, that'd be great. So the first question is, what is a typical hammer replacement schedule? I know this is very specific to each mill, but what is the general time frame?
Okay. And I'll start off by saying an answer you're going to hear a lot is it depends. It really depends on what you're grinding, how clean that material is coming in. Are you running 24/7? We a lot of times like to look at the amount of material ground. So I don't want to. I don't really want to throw any numbers out here because depending on the vast majority of materials that people are grinding on here, I'm going to have some very different answers. So I would say, and we can see who asked it, we will reach out to you and tell you what we would expect to see with your machines.
Yep, I think that's a great answer, Doug. I would agree with that. So the next question is, what is a screen change trade-off for replacing them before the hole exits? So basically, what's the trade-off between changing your screen early to get the most efficiency?
Okay, so those screens, there's two costs to look at a screen. There's a replacement cost and there's the operating cost. And obviously, the longer you keep that screen in there, your cost per ton in that sense goes down. For every additional ton you run through that screen, that price lowers. The curveball comes in at what is the efficiency of your machine? Because at a certain point, when those screens or any other wear items in your hammer mill get too worn, you will see your throughput or efficiency go down. And one of the biggest costs with running a hammer mill is actually spinning that motor on there. So if all of a sudden, you're losing 5, 10, 15% efficiency on your hammer mill, the couple dollars you're saving on keeping those screens in there longer is actually doesn't outweigh the additional energy costs you're putting in. So again, it's a hard answer to say based on what you're doing, but trying to keep an eye on what your energy costs are and keeping an eye on what your throughput are and kind of finding a matrix to see where that number is. You know, there's that sounds like a great project for an intern to put them on it, but getting a schedule to where, you know, whether it's every 1 week, 2 weeks, depending what you're grinding, is typically where it is. If you're seeing holes in it, I can guarantee you it is far before that time.
Next question. Why is the industry going to larger particle size for feed?
That's a great question. I don't have all the answers on that. From what I believe, a lot of it is they are trying to decrease the efficiency of how quickly those animals grow to slaughter weight, just because I know there are a little bit of supply chain issues to where if that they're not able to get rid of their animals as quickly. So I think they're trying to slow their growth. I could be a little wrong, but that's what I've perceived to be the reason.
Okay. Will you offer a similar webinar for roller mills?
The short answer is yes. We've gotten a fair amount of questions about those recently. So yes, I am looking to organize one for a roller mill. I don't have a time yet. However, I will say everyone who has registered here will keep your email on our webinar list, and you'll get invites for all future webinars that CPM puts on.
What's the optimum screen open area?
That one, again, it depends on the size of the hole as well as the application you're running. That one, again, I'd like to talk to you offline a little more about it to come up with it for you.
Okay. Do you have to change the hammer pins every time you change hammers?
Do you have to? No. We strongly encourage that you inspect them every time. If they appear to be in good shape and don't have any groovings in them, then yes, you certainly can reuse them. I mean, the safe bet is to always replace them, but it is possible.
Okay, we have a few more questions to go through. All right, let me grab one more. All right. All right, that was just people chiming in. I will give about another minute for anybody to ask any other questions, and then we will sign off. Doug, is there anything else that you wanted to cover before we do something?
No, I'll simply add, you guys should all have my contact information in the invite, and you will get it in the follow-up email you get it'll come from CPM webinars, but right here, there's my phone number and my email address. We're here for you guys. We're still working. If you do have any additional questions, always feel free to reach out to us. We're here to answer. We're here to help you out. We'll make sure we get you the answer you're looking for.
Okay, and I think the questions have stopped. So with that, again, just to recommend to reach out to Doug if you have any questions, and thank you everyone for your time.